We like to make these two sessions in this context of the DLT4ALL program and in this proof of concept or in this pilot that we want to show you the contents, practice with them, you interact with them in order to evaluate if these content are the best for these courses. That means that this session, it won't be, or I don't want it to be an unidirectional session. I prefer that, and I will try to make it as more participating possible and involving you in the different questions and in the different exercise and in the different context. So feel free in each moment to open your micro, open your camera, and interact with us. First of all, before starting, I would like to know about you, and I would like to know about you about what is your interest about this course, what is your experience about blockchain and cryptography, and what do you expect from this course. So feel free to present yourself and start with this session in this conversation. So who wants to be the first? I can see some people that I know well. Maybe I should start asking if you are online or not. Mm-hmm.
Sorry to interrupt, Pablo. They can raise their hand so we know when be able to open their mic. Well, we are the ones that can open mics.
We are the ones that can open mics. Okay. Okay. Attendees. Oh. Okay. View all attendees. They are not opened the micros, I think. I cannot open the micros from the people.
Cannot see the unmute button on the attendee list.
Yeah, I will hit the attendees list. Attendees, but
you have an option that is when you click on attendee, there is an option in the menu that is unmute me.
No, but it doesn't. I cannot. It doesn't allow me.
Does it work? View a participant. Unmute me. But Who is trying to host in this session?
No, I'm trying to.
Valentinos. Valentinos, can you hear us?
Yes, yes. You should be able to open microphones, but in any case that you cannot do it, just let me know the name so I can open the microphone.
Okay, I wanted to open the microphones of each one of the participants in order to present themselves and express their expectations. So if I cannot do it, if you can do it for me, we can open it in just in the order of appearance, or in this. The first one is Diego, then José Antonio, Luis, Nicolás, Pablo, and the last one, Simone.
Okay. Okay. First one, who should be?
The first one could be Diego, for example.
Diego. Okay, I'm muting Diego's microphone.
Thanks. Diego, good morning.
Good morning.
Good morning, Diego. Pleased to talk with you. Thanks a lot for inscribing yourself in this seminar. And in a brief introduction, I want you to know a little bit more about you and about what is your expectation about this course, and concretely in the cryptography and the relation between cryptographic and blockchain, please.
Okay, thank you very much. I'm studying my second year here at the university in Santiago. I'm studying computer engineering. Last year, I made a project for one of my teachers that was related with GPUs. My project was to choose the best GPU for a computer specialized on mining blockchain, Bitcoin. So I started learning a lot about blockchain. I like it a lot because I like a lot the mathematical part, because another of my teachers were explaining us how RSA encryption work and all that, and I like it a lot. Last year or this summer, I saw in Twitter of the university that this course was a pilot, and I would really like to take part. So see if in January, I think it was the full course, I could take part, because I like a lot of everything related with encryption and the connection between mathematics and computers.
Mm-hmm. Oh, that's great. That's great. It sounds great. If you are mathematical, you will understand quite well all the cryptographic references, and I'm sure that we'll enjoy some of the exercises and the reflections, and of course, how we use projects. The main point of this seminar is to understand cryptography, to understand how cryptography is used into blockchains, and to have a knowledge about the hash function. Okay? Yeah. Have you heard it before? You have worked with hashes?
Yes, the main project that I did last year was focused on the hash. Okay,
perfect. So maybe during the seminar you can also share any of your experiences, and if the hashes are unbreakable or not, and how we can deal with them. Okay, Diego, thank you very much. I hope that you will enjoy it so much. And let's give the micro now to José Antonio. That I think that José Antonio wrote me. Okay, now José Antonio, no, because he's not with open micro. I say hey, hi to him, and let's go then with, please, Valentinos, with David Araujo. Can you give him the open the micro? Thank you. Hello, David. How are you?
Hello.
Hello, David. how are you? Okay, my name is Pablo. If you didn't hear it before, we want you to present yourself and to show us what is your experience or what is your expectative about cryptography and blockchain inside of this DLT4ALL program.
Okay, I'm just surprised because I've just received the email for entering this web binder, and I'm just surprised. So I'm going to do it the best way I can. My name is David Araujo, as you have said, and I'm working for a company that is working for energetical efficiency, and my main working environment is around programming and several techniques involving encryption, hashing also, of course. And I've been very curious about the blockchain and how it might be involving our company in a very interesting way of, for example, certificating without any, for example, get sorry, my English. Energetical certification without any entity that will be being trusted. So I would like to get into this topic in a real way.
Okay, perfect. Thank you very much, David. As you will know, we have 2 days, today and tomorrow, that will be developing this seminar of cryptography and the link with blockchain. And that means that if you agree, we can start sharing the contents that we prepare, but please feel free to make any suggestion or any question, or if you want to go deep or any or slower or of any other concepts, because I can be available during all the day of today, and in this way I can prepare or I can reshare any content in order to adapt it to your expectations. So please feel free to participate, even here in the chat writing or raising the hand to talk and to make it more efficient in this way. Okay, thank you very much, David. Let's go ahead now with Luis Martinez. Please, Valentinos, can you open his micro, please?
Yes.
Hello,
Pablo.
Hello, Luis. How are you?
Good morning. Well, yeah, just a brief intro. Luis Martinez. I'm much more in the, I would say, finance and banking profile, but I have become acquainted with technology and more precisely with some encryption techniques in the last 3 years, becoming more involved in blockchain. So I got involved in the technology with a startup I personally founded, and I continue to work since then. So mainly working on tokenization and decentralized finance applications. But of course, since I would say 2017, I have been very developed much hunger for understanding these encryption techniques. I have studied a few courses, but I'm still a bit green. So I'm sure I will be one of the ones that will get the most out of this course. So happy to be here.
Okay, great, Luis. It will be great to have you here. It will be great to have people here with experience now in blockchain and to know and knowing and discussing about how we are developing blockchain solutions, how cryptography is the one or the main key of these solutions. Also, if you have experience about financial services, you will be close to any of the solutions that are on the table today that we are discussing about how the financial system or financial services are changing, and we can have time there to talk about it and how was the last especially the last 4 weeks, 4 months with all this movement called DeFi, and how this movement around DLT and blockchain, it's not new. We are taking tools that were developed in the past, like cryptography, but we are generating new value. So that will be great to have you here and share also your experience in the course. Of course, feel free to ask or to suggest or to put me in a thread about any remark or any question or any suggestion that you want to do. Okay, thank you so much, Luis. And now we continue with Nicolás Fraga. Please, Valentinos, can you open his micro, please? Nicolás, good morning. How are you? Nicolás, is it like in the TV show?
Hello.
Hello.
Good morning.
Hello, Nicolás. I was starting the countdown. If you okay.
Sorry, my bad.
No, don't worry, Nicolás. Nice to talk with you. We are making just a little presentation about who we are and what is our experience or expectation about DLT and blockchain, and in this course and DLT blockchain for all, and especially in this second module of encryption techniques. So
okay, so I'm a robotics student of the University of Santiago de Compostela, and I just wanted to get into blockchain and encryption techniques, as I didn't have too much idea of that. But I'm so interested because I think it's a very important part of the future. So I would like to understand it and learn more about it.
Mm-hmm. Okay, that's right. Have you ever been before integrated or involved in any blockchain project, or during your students groups? Do you talk about blockchain, or is just
no anything? First time.
It's the first time. So you come from the robotics world, and now want to explore about it. Okay, that's great. Blockchain is, of course, like the main title of the project says, DLT4ALL, blockchain for all. This is a technology or a group of tools or a group of technologies or a group of protocols that are open to anyone. One of the main changes in blockchain in these years, since the beginning in Bitcoin till the different protocols that we have now, is that we are getting more user experience with the applications. So it has to be close to only developers communities, or only freakies communities. It's a technology that aims to be open to everyone, and I think this is in the basis of this project, to open this technology to have access to this knowledge. So, Nicolás, please feel free to ask anything you want. You can ask it directly by the phone, by the chat, or even there. I will give you my email if you have any doubt or any of the topics that we covered today that you want to get deeply tomorrow, and I will be pleased to do it for you. Okay, thank you.
Okay, thank you.
Thank you, Nicolás. And then we continue with my tocayo, with Pablo Martinez. So please, Valentinos, can you open micro? Hello, Pablo. Hello, Pablo. Valentina, please, can you open now? Pablo? Pablo, good morning, Pablo. I think Pablo is maybe it's not available now, Pablo. Okay, Valentino, let's smooth it, please. And now let's go with Simone. That I think that I know who is him, and sure he has to tell us interesting things about blockchain. Good morning, Simone.
Good morning, Paolo. Can you hear me?
How are you?
Fine, thanks.
Pleased to see you again in this now in this format. So please, can you share with the rest of the people of the group what are your expectations or experiences in this blockchain world and with cryptography, please?
Yes, I'm actually working on my personal project that is Moto Blockchain. We are creating the digital identity for the motorcycle, and we are actually now in the decision of the blockchain technology and architecture to be used. It includes also the encryption, the hash function. We are also trying to understand if the hash is GDPR compliant or not, because there are some people telling yes, it is. There are European Union telling no, it is not, because when we will have quantum computing, it will not be. But now it is. So we are in the middle of this decision. And I'm always I know the blockchains evolve really fast, so I always go in every type of course, every type of webinar to try to see if I can learn something new, or in this case, maybe I can also bring something useful from your side, because this is a pilot. So yesterday they asked us to do some comments that could be useful. So maybe I can bring some comments from the customer perspective. And I hope also to be able to learn some technical, useful things about encryption.
That's great. That's great, Simone. That's great to see how we can see people thinking about what kind of blockchain should I use. Even that we can discuss about if encryption and the hash function, if you share the hash of any data, if you are vulnerating any of the laws, even when you are sharing encrypted data. And it's a discussion that we have now, and it's very, very, very hot, about how the data is shared, and if blockchain, and is it supposed to be, is the safest way to share this data. And this is because of the encryption function.
Yes,
So thank you very much, Simone. We will be talking during the day about it, and okay, you know me well. Feel free to ask anything you want right now or after this seminar. That's sure that we need to talk. Okay, let's go. Let's start then with this. Thank you, Valentinos. If you want to, we can close the mic of Simone for the, okay, for now, thank you very much. Okay, we will start with the content that we have prepared for you. As we did before, we must realize that this is a pilot, and with a pilot, we want to validate some data. That means that maybe some of the data that we can read here, it cannot be very interesting for you, or it can be very easy to understand or not. Please feel free to give me feedback online, and then we will try to improve the best as we can. So go ahead. When we talk about the encryption techniques, we must put in the context of why are we talking about encryption and why we are talking about in blockchain. That's why in these 2 days we want to get a deep view about the application of the cryptography in blockchain. To do that, we need to make an introduction of the cryptography. We will see different tools from the story on how it was used, the cryptography a long time ago, because there is a similar need now, of course, with another technology, but we're still using cryptography for that. We will see the hash functionalities. That means that is the main point and the point that will allow us to continue with the different modules of this seminar. We will talk about symmetric and asymmetric cryptography. We will see different protocols, and we make a view about how cryptography used in game theories. And with game theory, you will get deepest in the next module. When we will spend time tomorrow, we will spend time to understand how the applications are working on the blockchain context. No, so this first step, it will be more introduction and theoretical in order to tomorrow to watch, play, and see how is using other people cryptography on their projects. Well, as we all know, in this moment, blockchain is a technology platform that creates a distributed ledger between participants to allow transfer of asset ownership or transaction using smart contracts in a secure and permissioned environment guaranteed by cryptographic techniques and algorithms. Okay, we all know in this moment that blockchain, it was in the top mouth of a lot of people. We can say that during the 16, 17, and 18, we lived a hype of blockchain, and we all thought that blockchain will save the world and all of this. It was a part of marketing, but also it was because of the power of blockchain. Because blockchain, what gives us is the capability and the ability to send, to transfer data, and to make it in a secure way and without a third-party control. When we say that the importance of sharing data is that today, with the data, we can send value. We can send value. And this value, it can be realized in money, it can be realized in food, it can be realized in energy, it can be realized in whatever. So having the context and having the technology that allows us to send from one part to another part in a safety way is something that can change a lot of things in this world. That's why the focus of blockchain is important, and that's why we need to understand a little bit how important is cryptography during this session. Like we can see in this graphic, cryptography in a explanation that we can make to a little child or an old child is that the cryptography system is a system that allows us to convert readable text on unreadable text. That means that it can allow us to send data, to send info, but only the person that we want can read this info. In this digital area that we are living now, where we are obsessed with data and we are all the time working and generating data, it could be quite important to realize that not all the data that we send it must be readable. It must be readable, and we are talking about own data and privacy. All the cryptography techniques and algorithms are used in blockchain, have been around for a long time. I told you before, this is not anything good, anything totally new. We've been using cryptography since the beginning of internet. Since the beginning of the internet, we've been using hash functions. We've been using encryption functions, but there were all no need to us to know how about it. When we send, if you remember at the beginning of the 90s, at the beginning of the at the end of the 90s, when we started the voice over IP and to send voice in form of data to make the telephone calls, we were working with a lot of encryption techniques there, but it wasn't important for us. The only thing that we wanted to realize it was that if we can make a call or not. And now we are in the same situation. We cannot expect to all the people understand what is a hash function, or how do you encrypt, or what is your protocol, or whatever. We must realize on what we can do with it and why we do it. That's why we say that blockchain as a technology platform creates a distributed ability to participants to allow to transfer this information, this data, this ownership or whatever, in a secure and permissioned environment guaranteed by cryptographic techniques and algorithms. So cryptography is the function that allows to guarantee that this data can be transferred on a secure way. Well, about the story of cryptography, we can center in cryptos and Grashen as a name. And the cryptology started, we can say that we started in Greek from this word, and the meaning of hidden secret, and the meaning of how to show you anything, but you don't need to understand what is in this item that I'm showing you. The initial fundamental of this cryptography, it was that you can be living with different interactions, but you don't know what is going on in these interactions. Only the people that is authorized of understand it should have access to this info. And it's important for me to remark this since the beginning, because there, if we have this in clear, if we have in clear that we can share info or we can share data, that not all the people can understand it, only the people that we know can understand it, this is a very useful insight to understand what blockchains can do for us in this future. Another link in the story about cryptography, of course, is Egypt. We all talk about hieroglyphics, and we all know so many funny stories about how solve hieroglyphics, and of course it is at the beginning, and actually it's a really interesting exercise to do to play hieroglyphics. Don't forget it. After the civilization, after the Greeks, after the Egypt, we can talk about the Romans. Julius Caesar was known to use a form of encryption to combine secret messages to his army generals posted in the war front. The substitution cipher, known as Kaizen cipher, is perhaps the most mentioned stored cipher in academic literature. So we are in the context that we need to send info to someone, but we don't want others to watch this info. But we have the risk that someone can intercept this info, this data. So we need to send this info in a way that only the people who receive it is the one that can understand it. So we are talking when we have this review about the past and about how the cryptography appears in our lives, we can see that today we are having the same discussions. The security or the privacy of the info is the focus that have changed. During the Romans, it was because of they were playing on a war, and maybe they didn't want to know what was the strategy in the war. Now, well, we have wars in the world, but when we use cryptography in a typical lifestyle, it's because we want to protect the privacy of the data. And now these days, during the pandemic, we are very conscious about how the PCR test, the result, how we share the result. We have a COVID app to contact, and so we can see how the main purpose it is still the same, and we have moving it in different contexts. Let's see a little bit more about how, on a simple basis, cryptography works. That means of the typical example, or this is an example of moving the value of the letters. So when you say A, you move 3 positions on the alphabetic. That means that when you want to represent A, you write D, or at the other side. So that is a first step to start to encrypt that. And in a simple way, that was a good example. Okay, let's go ahead with a different historical movement. During the 16th century, Vigenère designed a cipher that was supposedly the first cipher which used an encryption key. In one of these ciphers, the encryption key was repeated multiple times, spanning the entire message. And then the cipher text was produced by adding the message character with the key character module 26. Module 26 is a mathematical expression. Diego Beltrán, a mathematical expert, or trying in the way to being an expert, will know about it. Modulo 26 is a mathematical expression which you calculate the remainder of a division when one number is divided by another. So in this way, Vigenère cipher can also easily be broken. However, Vigenère cipher brought the very idea of introducing encryption keys into the picture. So it was poorly executed. Comparing these two ciphers, the security of the message depends on the security of the encryption key rather than the security of the system. This is important because it changes how we can put now the focus on the encryption key and not in the message. And that's why in blockchain, we can move and we can transfer a lot of value because we are not focusing in the value. We deal with the same encryption if this value, if this data that we move is a cryptocurrency, is medical data, is a certificate or whatever, or the last DeFi protocol, because the focus is on the encryption key, on the key that allow us to disencrypt the message. We'll see before, after how to encrypt this message, okay? But it's important to have now the point of that the focus will be on the key encryption. We can see like in two different layers. No? One layer is the encryption layer, and the other layer is the key that allow us to read what is going on here. So it's like putting different layers of security. Okay. Well, introducing this in a formula, we can have K, M, and C, where we can have with this module 26 function the result of this equation. We can have a lot of exercise like this. Let's go ahead in this introduction at the start of the 19th century when the electric pulsar started. And that was important because the main point now is that we use encryption and key encryptions on a physical data. And when I say physical data, that means there is a physical support where the data are included. And now we are entering with electricity a new way to send this data. So we don't give it in the hand, we have electrical pulse to send it. So when Hebron designed an electromechanical contraption, which was called the Hebron rotor machine, it used a single rotor in use, which the secret key is embedding in a rotating disk. So not only the data was sent by electric pulse, it also allowed us to create powerful encryption and encryption tools. The key encoder and substitution table, and each key is from the keyboard resulting output of side protect. This also rotates like this, and by on one notch and a different table will be used to explain text character. It was again broken by using left filter. That was when we arrived to maybe the most known machine about cryptography, and is the Enigma machine. I'm sure that most of you know what is the Enigma machine and how it was created and for what and what was the purpose of the Enigma machines. Any of you wants to participate and tell us about the Enigma machine? You can write it in the chat, and if you want to say something about the Enigma machine and what do you know about the Enigma machine and the man who is over there, Alan Turing. Anyone wants to participate? You can write on the chat asking for participate, or maybe raise your hand. Okay, no one. Okay, let's continue then. Well, the Enigma machine, as I was trying to introduce you, was a machine invented by the German engineer Arthur Servius at the end of the World War I, and was heavily used in the German forces during the Second World War. The Enigma machine used 3 or 4 or even more rotors, the same rotors that we talked before. The rotors rotate at different rates as you type on the keyboard and output appropriate letters of ciphertext. In this case, the K was the initial setting of the rotors. Up to the Second World War, most of the work on cryptography was for military purpose, as most of the technology. Just think about the GPS that we have on our smartphones. The GPS started in the military purpose, and after so many years, we still we have democratic technology for use. So usually used to hide secret military information. However, cryptography attracts commercial attention for war, with business trying to secure the data from competitors. And this is a key point when companies, when industry, when business focus that one technology can give value to the company, they invest on develop it. And that was what succeeded with, and that what succeeded with these machines, with the cryptography. Business started to think what can be useful for this technology to them. I insist so much in this part, in this beginning, because if we understand the main basis of the cryptography, and especially this machine, we will understand what is the importance in blockchain to have Turing complete algorithms to send or to encrypt the data. So it's important to understand this part, even when we all read a book or we all watch a movie about Alan Turing. Okay. Okay. Now 1960, IBM, well known for all, is realized that the customer were demanding some form of encryption. We talked it before about the importance of the business and how the business see that this will give value to them. It happened the same with blockchain. With blockchain, we were talking about digital fiat, digital money before years, but at the moment that blockchain or the Bitcoin protocol, we must separate Bitcoin, the currency, and the protocol. When Bitcoin protocol allows or watches us to send value to peer-to-peer without a third in the middle, companies saw it like something interesting. But being linked with Bitcoin, it was not popular. So the buzzword blockchain, because blockchain is a buzzword, it's marketing, started to get higher. Okay, let's come back to 1970. I talk about how, thanks to IBM, they designed Lucifer, nice name, to a crypto machine, and they started to make different exercises and experiments. These experiments, this data encryption standard was not safe. And we can see that how in 1997, maybe one of the first hackers attack This was broken by an exhaustive search attack, and the main problem with this was the small size of the encryption key. As computer power increased, it became easy to brute force all different combinations of the key to obtain a possible plain text machine. That means that at this time, still at this time, the encryption, it was based on a limited number of characters. So that means that if you force the machine with more possibilities than the limited characters, you can break the system. In 1997, NIST again put on a request to proposal for a new block cipher, and it received 50 submissions. In 2000, it accepted Ringfeld and Christian with a new standard, the Advanced Encryption Standard. So, with a standard, it comes the definition, and with the definition, we can say that we have a mantra. Cryptography can be defined as the conversion of data into a scrambled code that can be deciphered and sent across a public or private network. Conversion of data conversion data of a scrambled code, and this code is the one that we share, and there will be a key that decipher this encode. Several terms related to cryptography: encryption, decryption, cipher, and key. 4 words that we must remember. Encryption is the process of plain text, normal text, to a ciphertext, random sequence of bits. We move this data to bits. Give me a second, because so encryption is this process. Okay, encryption. Decryption is the inverse process. We started in the encryption, we started in the random sequence of bits, and we convert it to ciphertext or plain text. Cipher is the mathematical function. For example, a cryptographic algorithm which is used to convert plain text to ciphertext. The key, it would be the small amount of information that is required to induce the output of the cryptographic algorithm. It's the key that will allow us to induce, to show us the cryptographic algorithm to be shown. Modern cryptography concerns about confidentiality, information cannot be understood by anyone, high integrity, information cannot be altered, non-repudiation, sender cannot deny his or her intention in the transmission of the information at a later stage, authentication, sender and receiver can confirm edge. All of these functions make concerns with cryptography. That means that cryptography is the tool or is the basis that allow us to have these characteristics. And as we know, most of these characteristics are inside of the whole definition of blockchain. So we can say, and we can say high, that blockchain in itself is a cryptographic system, okay? Modern cryptography, mainly based on mathematical theory and and computer science practice. Okay, let's do an exercise, and to make this exercise, I ask you to participate. So, if you are still attending, you will have your chat open, and I want you to answer these following questions. Just writing in the chat the answer. we all have the chat open. Please, can you write something in the chat? Are you ready for this exercise? Are you still on? Okay. Thanks a lot for your answers. Okay, let's go ahead with the first one. The first one is about the definition of cryptography. So, what is cryptography? Cryptography is a study of analyzing information system in order to study the hidden aspects of the system. It's a process of converting ordinary plain text into unintelligible text. Value used by algorithm to encrypt and decrypt, or the message to be transmitted or stored. You can put your answer in the chat. There is some people that yes is answering, so you can write A, B, C, or D. Give you 10 seconds. Okay, thanks, José Antonio. Diego. Okay. Oops. The right answer is B. Cryptography is a process of converting ordinary plain into unintelligible text. It's the main definition. Thanks, Diego, José Antonio, Simone, Audrey, for your answer. In cryptography, another question. What is cipher? An algorithm for performing encryption or decryption. The message to be transmitted or stored. None of mentions, both C and D. Now we have opened the polling, thank you. And we have time to answer it. Well, I don't know if all of you have answered it. Well, all of you thought about it. The cipher is an algorithm for performing encryption or decryption. In the polling, I cannot write. Okay, thank you, José Antonio. We will continue then here in this chat. Well, let's see then all this mapper of how is cryptography organized. Cryptography or techniques of cryptography we can have classified in covert and overt. In covert, we will see then a description of each one. Huh? In covert, we can have steganography, digital watermarking, and in overt, we have hashing and encryption. And in encryption, we have the symmetric private key and asymmetric public and private key. In blockchain, the two ones we use are hashing and asymmetric. So inside of all the cryptography classification or techniques or whatever, we focus it on hashing, cryptography over hashing, and cryptography over encryption asymmetric. So it's important to put the focus on it because we must remark that this is not about being maximalist. When I am maximalist is that we don't need to defend that this is the best or the only question or the only way to make safe communication. There are another ways to cryptography that are quite used, but in blockchain we use these ones. We've been talking from the classic cryptography to the modern cryptography. There were, as we talked before, with the Greeks, the Egyptians, the Romans, during this period. We will be talking also cryptography during the Renaissance, also with the first wars, but in the modern cryptography linked to the revolution industrial and now linked with the digital revolution is where we are watching more uses or watching more powerful values of uses of cryptography. From the last to the newest, we will make a review of different tools that can give us insight and inspiration on our blockchain project on how to use cryptography. The hieroglyphics, these tablets, Mesopotamia. This one was quite useful. Now even we can use it as a tool. And it was an site tale was first mentioned the Greek archaeologists who lived in the 7th century before Christ. The ancient Greeks and the Spartans in particular are said to have used this cipher to communicate. Sender and recipient each has a cylinder of exactly the same radius, and the sender won a narrow ribbon compartment around this cylinder when wrote a lengthwise. After the ribbon is unknown, the writing could be read only by a person who had a cylinder of exactly the same radius. It's a sort of cipher, no? It's a sort of who have the key to understand it. For example, if the original message was, will king tomorrow midnight, kill king tomorrow midnight, write lengthwise, kill king tomorrow midnight, and the encoded message will be KTM, we can see from the top to the bus, KTM, IOE, LMD, LON, KRE, I, IRG, NOH, GY, GW. Sorry. So it's a simple or not that simple. It's a way to encrypt the message that it won't only fits if you have the same cylinder. It would only have the same cylinder. Of course, if this cylinder is a common use object and no one knows that it could be used to decrypt message, it will be something useful, something funny, and something that you will have always to play with it and to remember it. Another Greek method was developed by the Polybius, and we have the Polybius square. Each letter, A, B, C, D, F, G, H, I, G, represent by coordinated 1, 2, 3, 4, 5, 1, 2, 3, 4, 5. So the O is represented by across the two numbers, the 3 and the 4. So use the grid to transform the VAT sequence of letters. Answer in the chat. How do we transform VAT using this Polybius? It will be a sequence of numbers. So if anyone wants to share, which will be the resultant number, please feel free to write it. Okay, it will be something like that. One, two, one, 4, 4. So if we send this message, 121144 or 121144, we are meaning VAT. Let's take a look to the Roman Caesar cipher. The method is a name that Julius Caesar who used to communicate with the general. Okay, we mentioned it at the beginning. Let's see how it works. A means D, B means E, C if. Okay. Let's go ahead with other ones. The Hebrew scholar may use mono-alphabet substitution ciphers, like the Atbash cipher. In a specific case of substitution cipher, where the letters of the alphabet are reversed, in other words, all AS are replaced with CS. ZS, all BS are replaced with YZ, and so on. Aikindi, Nabuk cryptography, the Risala, Fitis Salah Muhammad, manuscript of the cipher cryptography message. We can see how during the story we have the different methods and more close, the first one or the oldest one, more close to brain games or logistic games. And since the Renaissance, we started to see how the polyalphabetic cipher of Leon Battista Alberti, well, it goes a little bit deeper. The cipher alphabet for the first letter, you know, this is the sequence. This is for the second letter. So in this way, we can write letters, we can write words, but with different characters, and knowing that if we use this, we can send message that not all people can understand. Concerning to the words, we started to work it as a systematic method. it was not to send one only message in one concrete situations, we started to need, like in all the words, to make it on a systematic way. So at the first big words, they started with these more simple systems, and when it appears Enigma in the Second World War, where they were using it in a much complicated way. Coming to our world, we see how it is used in the modern era of the cryptography. Really begins with the Claude Shannon, the father of the mathematical cryptography. We're moving from the alphabets and the polymetric alphabets, and we are moving to the mathematical cryptography, establishing a solid theoretical basis for cryptography and also format for crypto analysts. And with that, cryptography more or less disappeared into secret government communication organization, NSA or whatever. So we have the cryptographic inside us. Okay, we have made a deep review of how cryptography appears in our lives, what cryptography can do, and remembering this diagram, how it is important for blockchain to arrive to this point, to understand this point of hashes, that is the main point or the key point of this module, because it will be the link with the module 3, and also it will be the main function that we should understand to develop blockchain solutions. The concept of hashing that we see that it arrived from the cryptography onward. Let's see a little bit. I don't know if you want to make any question at this point. If you want to make any question or write it at the chat or raising your hand, we can give you voice if you want to make any remark or any question about it. No? Okay. Okay, let's go. Hash functionality, let's go. We have put it in hash in the map. Now see what its hash function and how it works. Hash function is defined as a set of procedures and steps or a mathematical function that can be used to convert a large amount of data into a small data stream and integers that can be used as an index as an array. For example, for means that allows us to use a lot of information, convert it in small data that can be transferred, that can be used. For example, if we have a private document, like it can be the results of a medical analysis, that we want to share it with my doctor, and because it is a private information about me, and I don't want anyone, I want no people watching it and having access to it, I need to have this 12 pages document to reduce it to send to anyone. In the far west, these 12 pieces of papers maybe could be put in an envelope, would be linked with any kind of glue and sent to other people, certified, verified by a third party. With digitalization and the hash functionality, what I can do is all this data I can reduce, I can transfer it to digital format, OCR, photography, whatever. And once I have it in digital, I can represent all this data in a hash function. I mean, I can convert the data in a hash function. That's why it is really, really, really important to understand that when we are talking about digital transformation, we are talking about data. We are talking about convert to data and then to work with data. So here, what we are doing is that the hash function means a function that compresses, meaning the output is shorter than the input. It's a way to reduce, to make it simple. Like in the 90s, with the telecommunication operator started to work under the voice IP protocol. The voice IP protocol, what allows us was convert our voice on a data signal. And once you have the data signal, you have the internet, you have the LAN connect to send it to any place. That's why a hash function takes a group of characters, called a key, and maps it to a value of a certain length called a hash value or hash. You convert this data into these characters, and these characters, you give it a value and a dimension that is a hash. So you can have different kinds of hashes. The hash value is representative of the original string of characters, but is normally smaller than the original. This term is also known as a hashing algorithm or message digest function. Hash function, also called message digest, are one-way encryption or hashing algorithm. Important to have it clear now. One-way encryption. It only goes in one direction. This hashing algorithm. A hash function for any file can be generated to create a digital fingerprint. Okay, we have. I'm sure that this concept is not new for us. It's almost impossible to alter the file in any way without changing the hash function of that file. So this is a good way of checking if a file has been changed or corrupted. If I have my medical file digitalized and converted in an algorithm, if any of the data of the medical file is changed, when we try to convert it again to the algorithm, to the hash function will be different because the data was changed. That's why we use this function of the hash to demonstrate, to keep, to make it a document incorruptible. Incorruptible means that we can verify that if this document was modified or not. Okay? So with the hash data, with the hash function, we can approve and we can be serious about if a document, if a data was changed. It's also widely used for checking that download files are exactly as the ones still on the server. If you have a copy in the cloud, if you want to download a copy, it uses to check if your copy downloaded is the same that you have over there. Which is why there's sometimes in the file number of the download. Take a look at this if you see it when you download a page of a website. Another application is the encryption of password of operating system. We all use passwords. We all use passwords referenced about a number of our pet, kids, friends, whatever. But when we send this message to check if the username and the password is correct, the info is sent by a hash function. In this, not send the name and the password. Convert the name and the password, converting in a hash function, and if this hash is the same that the hash that it is stored on the server of the page that you want to achieve, if it is the same hash, it opens you the access. If it's not the same hash, you cannot open the access. For instance, talking about security passwords, when someone asks to make a security password, we use minimum 8 characters, number, letters, lowercase, and special characters in order to make a first security pass with this complicated number, and then a second one with a hash function. Well, there are various applications of hash function, and the most common of is using hash tables. The hash tables are mainly used to quickly search a data record using a given search key, where the hash function is used to map the search key using a generated hash. It's the definition of what I told you before. We have to search a data record using a given search key. And if the hashes are coincident, it will open. It also used to eliminate redundancy. If we deal or if we work with a hash that refers to a document, it will be easy to evitate one of the main or the common problem that we have with documents, and is the duplicated documents or the different versions, because we can be working on a different version, or we can be working on a duplicate document and we don't know it. But if we work since the hash, we all will know if we are working with the adequate or with the right document. Caches. Hash functions are used with hash tables to build caches for large data sets that are stored in a slow media. This highly improves the performance and reliability. Thanks to the hash function is why blockchain is being observed as a solution for the data storage, because we don't need to have our data, all our data, storage on a single place or even in a cloud. You know, at the back of the cloud, there is always a computer. If we use the hash function, if we can storage our data on a decentralized way. There is a great project that I call right here that is called Swarm. The Swarm project aims to be the biggest decentralized storage platform for documents, and is because it uses the hash function in a blockchain built, in this case, built in Ethereum. Swarm project. Hashes Bloom filters a compact data structure that uses hash function and hashes. Pather machine string search algorithms like Revin-Card uses hashing to compare strings with time complexity of O(n) or average. Geometric hashing used to solve many proximity problems in a plane or 3D space. This is further used to image recognition, processing, and matching. It's even used in telecommunication to encode and compress multidimensional signals, and it's known as vector quantization. This one, it's really, really important, for example, in the autonomous car. We are talking about the revolution that it will suppose, the autonomous car, but one of the points is the safety. And the safety is about that the autonomous car needs to communicate in a safety way that what is going around the car, it's real. There is a first problem more linked to satellite problems. Also with the 5G, it's supposed to be solved in a part because of the speed of the transfer, but we know we don't need only speed, we need also security. And this hashing will allow to be sure that the figures, and when I say figures, I can say also people that are going around the car are exactly what the machine that is managing all this artificial intelligence is understanding that this is a person, or this is a cat, or this is whatever. Cryptography has function, cryptography has function is a special hash function that has 3 properties. Pre-match resistance, the function should be irreversible or one way, where a given hash H, where it will be difficult to find any message M such H equals hash M. And when M is the message. The second, pre-match resistance. The function should not produce the same hash for 2 different messages. Given a message M1, it should be difficult to find another message M2 where M1 equals M2. That means that the hash, the M1, it will be the same as the hash of the message 2. So we need this second pre-image resistance. And the third one, the collision resistance. That means that the function should be collision resistant, where it should be difficult to find 2 different messages, M1 and M2, such that the hash M1 equal to the hash M2. Birthday attack, for example, may be used against the hash function to find a collision. Some examples are MD2, MD4, in SHA. This SHA encryption model is one of the hash function that we will have to keep it in mind to understand later how it works in blockchain. Remember the SHA. Hash machine authentication on code combines authentication via secret shared by hashing, message digits MD2 byte oriented, MD4 similar to MD2. Well, we can see different one as we arrive to the secure hash algorithm. Is the one that I say that you must remember, SHA. That is a model after MD4 and proposed by the National the secure hash standard, national secure hash standard, and is the one that produces 160-bit hash value. The HHA, secure hash algorithm. Remember it because we will use it on the next steps. So how it works in a physical way, and we are going to the last 20 minutes of this session of today. Message B, arbitrary length. It enters in the hash and it gives us a hash value in fixed length, the length that we fixed. It's, as we saw in this kind, we can see visually. We have a lot of info and we reduce this info. Okay, we reduce this info to manage it properly. So encryption, as a definition, is a method of transforming readable data, called plain text, into a form that appears to be random and unreadable, which is called ciphertext. Plain text is in a form that can be understood either by a person or a computer. This game of either and a computer, it will have a sense that we will see after. Once is it transformed into ciphertext, neither human or machine can properly process it until it is decrypted. So this is the encryption method. How to see it? Encryption, we have plain text, this plain text with a key, we throw it through an algorithm and we can have it in a ciphertext. Okay? We need the key and the algorithm. At the other side, if we have the decryption and we need to decrypt it, we need even a key and this algorithm, this function, to have the plain text. We can see how the text is the same and we represent it on different ciphertext. So this is the process. The hash functionality is the process of converting this plain text to ciphertext. Hash functionality is to convert the plain text to ciphertext. Big amount of text, we collect it into a ciphertext. Also, encrypted data appear random encryption process in a logical, predictable way, so that a party receiving decrypted data and in possession of the key used to encrypt the data can decrypt the data, turning it back into plain text. Truly secure encryption will be complex enough that a third party is highly unlikely to decrypt the ciphertext by brute force. In other words, by guessing. Okay. So the main point is the same. The main point is we have data, we need to move this data, so we have a hash function that allows us, thanks to the encryption, to convert all this data, as we saw here, on a ciphertext, and then we can send the ciphertext in a security way. A cryptographic key, as we saw it before in a small definition, is a string of characters used within an encryption algorithm for altering this data until it appears random. That is, that we can have, maybe we can have access to one of these encrypted, we can have access to one of these ciphertexts, but for us it will be only data without sense. There are two main kinds of encryption that we use, symmetric and asymmetric. Asymmetric encryption is also known as public key encryption, another word that we have to make a remark attending to blockchain, the public key. In symmetric encryption, there is only one key, symmetric encryption. And all communication parties use the same key for encryption and decryption. In asymmetric or public key encryption, there are two cases. One we use for encryption, and there is one used for decryption. That means that we can have privacy by our own, or we can share between people this privacy. Either we can be used for either action, but data encrypted with the first key can only be decrypted with the second key, and vice versa. One key is kept private, while one key is shared publicly for anyone to use. Hence, the public key names. Asymmetric, the public key encryption. Asymmetric is the foundation of the SSL or TLS that we should know that is one of the encryption of the secure encryption that we use when we send emails and when we work in the public domains on the internet. We say the TLS certificate, and we can watch this kind of security here. Privacy. Privacy ensures that no one can read communication or data at rest except the intended recipient or proper data owner. This prevents attackers and networks, internet service providers, and in some cases government from intercepting and reading sensitive data. When we're talking about privacy on this data encryption, privacy. And security is that encryption helps data breaches, whether the data is in transit or at rest. If a corporate device is lost or stolen and its hard drive is properly encrypted, the data on that device will likely still be secure. Similarly, encrypted communications enable the communication party to exchange sensitive data without leaking the data. Encryption also helps prevent malicious behavior such as on-path attacks. Authentication. Public key encryption, among other things, establishes that a website origin service owns the private key and therefore was legitimately issued an SSL certificate. See what is public key encryption to learn more. Regulations. For all these reasons, many industry and government regulations require companies that handle use data to keep the data encrypted. Example of the regulatory and compliance standards that require encryption includes HIPAA, PCI DSS, and the most famous for us maybe the GDPR. So we need standards to protect several information that are based on this encryption, that this encryption are one of the has functionality. We can see the line how it goes. Just finishing, encryption algorithms. Encryption algorithms, the mathematical formula used to transform data into ciphertext. Remember, the big data, we want to convert it to ciphertext with a hash function to transfer. An algorithm will use the key in order to alter the data in a predictable way so that even though the encrypted data will appear random, it can be turned back into plain text by using the key again. This is how it works. And this is how it's important to keep safe this key, because the key is the one who can decrypt. In blockchain, Bitcoin especially, Diego, that you were talking at the beginning about Bitcoin, when we are talking about that you don't have the coins if you don't have your key, it is because if you don't have the key that allows you to decrypt that this data, these coins are yours, you don't own them. That's why we must be very serious about how we keep this key. But commonly used encryption algorithms, Blowfish, RC4, DES, 2FIS, there is such a way. Other concept, the forced attack. A brute force attack is when an attacker who doesn't know the key for decryption attempts to determine the key by making thousands of millions of guesses. Remember, like we saw here, that the data is altered in a predictable way. So if we force two different predictable guesses, this kind of attack will make will make us a little bit of danger. Brute force that are much faster with modern computers. Now realizing that we have or we are going to the e-quantum computer, these e-quantum computers can make all these predictable guesses more frequently and more constant. And that's why encryption has to be extremely strong and complex. Here's where I have to say that as much more goes on e-quantum capability, also for computing, also for encrypting, also for decrypting. So we are moving in the same loop. Most modern encryption methods, coupled with high-quality passwords, are resistant to brute force attacks, although they may be in the future as computers become more and more powerful. Weak passwords are still susceptible to this type of attack. That's why the recommendation is always to have a password of more of 8 or 12 characters. Okay, any questions at this point? I would like to receive some feedback from you. I know that maybe this part we are in this context of the pilot, but I know that this part could be for some people maybe quite deep. For other ones, could be quite bored. So please feel free to make now a little discussion about it, or a little impression about it, and with that we can finish this first session of 2 about this DLT4ALL program. So if anyone has something to talk, please feel free to write in the chat or raise your hand. Does anyone wants to share something with us? I can see that we still have 6 people connected. Nicolas, maybe, are you available to talk a little bit? I don't know, Valentinos, if you can open the micro of Nicolas, please.
Hello.
Hello, Nicolas, how are you?
I'm fine.
Fine. Okay, I asked you before, you were the last one in the first row, so you appears in the first place. And also, well, to share with you what was your impression about these first 2 hours, about the concept of encryptions, and the concept of the hash function, and to give us some feedback about what you like or you don't like, or what do you expect or what you don't expect.
Yeah, I like it, but I had some audio problems,
Okay.
so I missed a little part.
Okay.
But yeah, it was what I expected, because at first, obviously, this has to be theoretically. So yeah, I enjoyed.
Okay, perfect. I think that it's being recorded, so maybe you can watch it later. And of course, we have tomorrow too. And if you have any question, any suggestion of if we mention tomorrow any term that you don't are familiar or you don't know about it, please feel free in the chat or raise a hand to tell me, and we can make a refresh, and it will be great for us.
Okay, thanks.
Thank you, Nicolas. Now change to Luis Martinez. Valentinos, please, can you move the microphone to Luis if it is available? Hello, Luis.
Yes, thank you, Pablo. I thought it was a great introduction. Learned a lot from the, let's say, the history and the beginnings of the technology, and obviously its, let's say, historic purpose. But yeah, it would be interesting learn a lot about the hash mechanisms, and it would be interesting to get maybe a little bit deeper into the different hash functions, and you know, the recommended uses for each hash function, and these kind of things would be something nice to learn.
Okay, perfect, Luis. Thank you so much. As well as you are a more advanced user, this is a very important feedback. As you know, there is an introduction about the context, but of course the link of the hash function and blockchain is the main purpose of the seminar. So I received this feedback to this first session, and during the second session, I hope that I can give you more info and get it deeply and to cover these expectations. Thank you very much, Luis, for your feedback. And we continue. I don't know if Pope, Jose Antonio, if it is available. I know that he was on a meeting board, so maybe we can jump or skip it and receive his feedback in another moment. Now we can move to Diego Beltran. Can you, Valentino, pass the micro to Diego, please? Hello, Diego. Hello, Diego. So please.
Yes, I found it very nice. You have go through a lot of very important concepts in just an hour and a half. For me, it was very good explaining. If may, I will recommend just a little bit more of the mathematical part, just in the asymmetrical encryption, because when in the university they explained me asymmetrical encryption, when I really understand it was when they explain the mathematical part, because there is where you can see the difference between having a private and a public key and only have one, because for the function, to see that the function, you cannot make the inverse function. That was when I really get it, and I think that could be very useful.
Okay, perfect. And it's like I told during the presentation, and I make a remark of it because of the link of the public and public keys to manage your data, in special when you're talking about cryptocurrencies. We can make a key point or a hard point in this concept of asymmetrical encryption, because it's, as you say, it is really important, and it's more than complex to explain. It's easy to lose the benefit or why it is necessary. So
yes, because yes, I have spoken with many people that they don't really get the difference. They think that it's similar, but it's very different, and I think that's very important too.
Yes, I agree with you, Diego, and thanks so much because it's a really, really good feedback because we can make maybe an exercise even, or we can make a key point, a hard point of remark the importance of the asymmetrical encryption with the private and public key. Okay.
Yeah, for me, if at the university they give us an example of just two prime numbers, they very small. Imagine 7 and 11. And they calculate us the asymmetrical function, and was very visual because you were seeing how you multiply the prime numbers, how you get the phi function. For us, was very useful.
Great. Okay, that's good. That's a good example, and I will document it to include to the course. That's great, Diego. Thank you so much. This is a great feedback. And just to begin, David, please, if we can have the micro to David. Hello, David. Are you over there? Hello.
Hello, Pablo. Thank you, first of all, thank you for all your dedicated time for teaching us the different types of cryptography. It was very interesting, the introduction that was being made for historical events that lead to our knowledge on cryptography. Nevertheless, what I think I kind of miss from this will be more about ensuring the importance of what means that cryptography has been compromised. For instance, something that came to my mind was the collisions that are, for example, for the MD5 from the hashing, and also what has mentioned by Diego, for example, the concepts from RSA for the asymmetric encryption, as well, more about the computer cost that lead to the importance for a good hashing system, and also a very cost system that allows to avoids using brute force for example, destroying hashing algorithms, salting the message, or some kind of things that, for example, avoids using rainbow tables and so on. That makes secure the block that I think for my knowledge it's, for example, using the SHA-256.
56, okay.
So I think it's, for example, not using very lightweight version that makes very secure the blockchain. So.
Okay, thank you so much for this feedback. It's also very interesting to maybe to have also the theoretical and also the practical view of how the hash function is working. Really interesting to talk about the cost of the hashing systems and what kind of computers or how a computer can solve or can help with that, and also how the data can be compromised or we can have collisions with another hash. So I take it in consideration in order to improve and to make a deeper understanding of this asymmetric encryption inside of this DLT blockchain function. So thank you very much. Thank you very much. I really appreciate it. So if you agree, some of you told me that you need to move from Moscow to at 11. So if you agree, we can make a stop here. I can be available. I can write you here in the chat an email address. So if you want during the day of today, write me, contact me to anything, please feel free. And in this way, we can return to this point tomorrow, where we will be talking about asymmetric encryption, symmetric cryptography, maybe some of the remarks that you made now will be talked tomorrow. I will check that all this feedback that you give me now, it will appear tomorrow, and in order to make a better course, a better seminar to the following students, to the following participants that will be on this program. So thank you very much for your time. It will be my pleasure to show you a first view about how these systems are working. As I told before, maybe at this first moment, a little bit theoretical, trying to make it to a mix of theoretical and practical, and we will continue tomorrow at 9 a.m. And I hope that it will be at least as well as today. Thank you so much for your time, and see you tomorrow. Bye.